FLL was a lot different this year with remote working and not many face-to-face meetings. But we didn't let that slow us down. We adopted some huge goals and found new ways to work. We spent the summer learning Python and became experts in doing Lego CAD. In the end, we built a robot that can get 600 points. We think that's every point on the board, and shared our new way of working with hundreds of teams all over the world, and were even featured by First.
Our engineering process this year had to adapt. We started by individually studying each mission on the board and brainstorming approaches. We had at least 2 people assigned to each mission, and we came up with at least 3 different solutions. As a team, we decided which approaches to try. Everyone took a couple of missions and built prototypes. There was a lot of testing and iteration at this point. This gave us a proof of concept for every mission along with key measurements and specifications so that we could design attachments that could do multiple missions.
We then had a whole team brainstorming session on how to combine the missions into runs. We came up with a theory on how to do them all. Next, it was back to CAD to complete the attachment designs that would combine the missions. We used online team meetings to review designs and suggest improvements. We even built 3D models of all the missions and gave them away on our website. We built the attachments at our houses. Then, we programmed in Visual Studio Code and tested at our houses. This resulted in a few more changes. Lastly, we did lots of consistency testing and recorded our data on Google Spreadsheets to make sure our missions were consistent and to find any last issues.
Our robot was designed in CAD, where as a team, we reviewed and improved the design through a number of versions. The robot was designed to have easy on and off box attachments and areas for clips to attach to the robot to ensure that the attachment will stay on the robot. Additionally, we have wall riders to ride walls and 4 color sensors for maximum speed and accuracy. The robot was made to have a strong frame so it wouldn't break easily and could have balanced weight from the front to back. The attachments that we design are built for strength and efficiency. Designing in studio and having team reviews has really improved our approach in this way. The attachments combine a number of missions into one run and can integrate with the 2 medium motors in our robot design.
Even though Python gives us great control over the robot's movement with smooth acceleration curves, it is not enough for long missions and extreme accuracy. So we also use the environment and sensors constantly. Our robot has a light sensor in each corner to navigate around the board fast and consistently. We use them to constantly correct the robot's longitude, latitude, and heading. We also mechanically align on mission models and walls to further increase accuracy and consistency. We even use motors as sensors. In the treadmill mission, our code notices when the medium motor slows down to know when we have made contact with the treadmill.
For coding, we decided to try Python instead of Mindstorms this season because of many advantages, like the built-in support for smooth acceleration. The ability to control the duty cycle of the motor allows for easy resetting of attachment positions, and the support it has for complex gear train math. But maybe the most important advantage of all was the ability to organize our code much better. Our object model has a robot class for reusable code library with common methods that we can use for all of our missions. We also have classes that represent each of the missions and classes that handle the overall mission control and custom user interface we created for the brick. Finally, the ability to use Git, a source code control system designed for teams, was critical to allowing us to all work independently but on the same code. Python was such a huge breakthrough this season that we made a video showing other teams how they could use it and added it to our YouTube channel.
Finally, we are proud of our innovations this season. Our rake of infinite utility has retractable teeth and can complete 6 different missions on the board. Our robot pull-up attachment uses linear motion created by the linear actuators to drive a rack gear, which places the health units. We even built a rubber band-powered autonomous vehicle that locks the step counter while the robot is off doing other missions. When our team was looking over the board, we realized that there was 1 extra cube on the shared model that we didn't send over. So we created an attachment to retrieve it to drop it into the frame. The rules don't say you can't. Thanks for watching, and we are looking forward to talking with you.